Okay. All right. Well, welcome back to school, everybody. It's fall quarter, start of the school year. I don't know. I think we're all excited. There's I think are all of you guys seniors? Anybody here not a senior? Okay. Oh, okay. There's a handful of you. All right. But most of you guys are seniors, and this is kind of probably your last sequence of classes 102. You know, you gotta finish this and graduate and all of that. And so anyway, I'm excited to be teaching this class. My name is Miles Chen, and I'll be your teacher for the quarter. And I'm excited to have you all with me. And our class is Introduction to Computational Statistics with R. Okay, you guys have all taken Stats 20, correct? Anybody not take Stats 20? Okay, excellent. So I'm not going to spend any time covering the basic R stuff that was covered in Stats 20. I mean, we will go over, I guess, some of the fundamentals, but maybe at a slightly more detailed view here. And well, I guess we'll take a look at our syllabus, and I'll just point out a few things here. Maybe I'll just. All right. So, well, I guess this will we'll go through all of this in the presentation. But the course is kind of thematically divided into two parts. The first half will be we'll focus very much on some of the packages in R, some of the kind of programming skills that will be fundamental as for the future of your kind of computational statistics experience. And then the second half of the course will cover some of the introductory topics in computational statistics. And I'll get to explaining exactly what computational statistics is in a moment. Okay, I've got office hours, Mondays and Fridays, 1 to 1:50. So, you know, our class is at 2 o'clock, so it's pretty much the hour before class. And if you've got class or you've got something else preventing you from coming to office hours during those times, just send me an email. Generally, I'm on campus only Monday, Wednesday, and Friday this quarter, okay? So if I don't have anything going on Tuesdays and Thursdays, and so I don't even bother showing up to campus, okay? So I apologize for that. The office is in Math Sciences 8105. There's like a keypad on the door. Usually I'll try to have it propped open during office hours, but if it's closed and it's locked, you can call my office number there. Everything will be posted on CCLE. And these are the dates of our exams and software you're expected to use R&R Studio, which I believe you guys are all familiar with. Okay, we're going to have a few books. I've tried to pick books that are freely available for you guys. So I don't know if you guys are aware, but being a student at UCLA, UCLA Library subscribes to a lot of kind of online library systems. And so this quarter I was able to, I mean, for this class, I was able to all find textbooks that I liked that we have subscriptions to. So, you know, you can just kind of click these links in the syllabus and it will take you to here, and you just have to download the PDFs of each chapter, okay? If you really want to get a physical book, you can spend your money and buy a physical book. I'm totally now a huge fan of digital textbooks. I just read it on the iPad and things like that, and I can carry my entire library on this small device, and it's the best. But anyway, that's what we have. If you're at home and you want to access the book and you're not living on campus, then you will have to connect to the VPN, okay? Otherwise, the website will say, you are a stranger and I don't know you. So if you don't know how to connect to the VPN, I've got a link here. just type in UCLA VPN. The #1 hit will be instructions on how to use that. Okay, and then yeah, this one, unfortunately, there's no PDF of it available. You have to read it in your browser. But this, you guys know about Safari Books Online? Yes? No? Okay, well, I'm telling you now, this thing is amazing. It's pretty much the entire O'Reilly catalog of books. I don't know if you guys know about the O'Reilly books, but you know, they all have like some strange animal on the front, and it's all about like programming on the not a strange animal, but just some kind of I don't know why. You know, our graphics cookbook has a, what is this? And moose, elk, something. Okay, something, right? Somehow that represents our graphics. But anyway, entire O'Reilly catalog available for you free while you are connected to the UCLA network. After you graduate and they turn off your UCLA account, you lose that. So take advantage of it while you're here, right? Okay, this is how we'll do the grading. We're gonna have 6 homework assignments. Each of them are worth 8%. None of them are dropped, so make sure you turn them in, okay? 20% midterm, 25% final, and then 7% will be on class attendance, and I'll take attendance on arbitrarily selected days. As far as homework, you're gonna submit everything as rendered HTML files. So I will post them as R Markdown files, and you'll edit the R Markdown file, and then you will render it as HTML and post your rendered HTML file, okay? Maybe I should add some stuff here, but just keep in mind that there's like 75 of you, okay? And there's one person who's grading everybody's homework assignments. And so this person is not going to spend more than 10 minutes on your homework assignment grading it, okay? Even at 10 minutes, that's like 10 hours of work, okay? And so you want to make sure that when you submit your homework, your answers are very clearly indicated as answers, and you know what it is that the problem is looking for is very clearly indicated as such, okay? The code might say, the problem might ask you to write some code, okay? And you might write code that is perfectly good, but you never actually, but if you don't run the code and demonstrate that the code actually does what it's supposed to do, the grader has no way of determining if this code was successful, right? So you got to keep that in mind whenever you're submitting your homework. You want to make sure that you are presenting what it is that that you have done to make sure it's be graded. I'll put a reminder up on CCLE. Okay, late policy for homework. All right, 10-minute grace period. Okay, so if you submit it, so generally I'll try to make my homeworks due around 6 p.m. Okay, and so if you submit it at 6, 10, 59, and this is, we're gonna go off of what CCLE says when you click that thing. Don't say like my watch was different, okay? We're gonna go off of what the CCLE server says, okay? If you get it in here, no penalty. If you miss it by a second, okay, that's a 5-point penalty, okay? And everything after that, it's each hour you lose 5 points, okay? But I'm a firm believer in everybody needs to get their sleep, so there's no penalty between midnight and 8 a.m., okay? So even if you didn't finish, go to sleep, okay? You gotta get your sleep, okay? And then the penalties resume during the waking hours, all right? Because you guys, you need sleep, all right? That's, if I did college again, I would sleep more, okay? All right, so anyway, just make sure you, when I post a homework assignment, look at the due date, mark that date in your calendar, okay? Don't accidentally say like, oh, I thought it was due on Thursday, but it was actually due on Wednesday or something like that, okay? If you do something silly like that, you're gonna be in big trouble, right? It's just like sending in your credit card payments. If you say, oh, I thought it was due on the 14th, but it was due the day earlier, then now you got your, you're going to be rebuilding your credit for the next 7 years. Okay, so everybody has a credit card, and everyone pays off the balance every month. You don't want to, anyway, all right. Credit card companies are not making as much money as they used to because nobody keeps a running balance. So, well, anyway, all right. Okay, if life happens and you need an extension on homework, I'm generally pretty accommodating, but I do have to ask for some kind of documentation of the thing, okay? You can't just say, I wasn't feeling good and give me an extension. But, you know, if something did happen in your life, if you have any kind of documentation, you know, provide that, and I can give you an extension or a makeup exam or whatever it might be. Okay, so that's written out there. Attendance, I might do attendance the old-fashioned way by calling your name and seeing if you're here. There's a thing called online poll that we might try to use that will maybe speed up the attendance process. We'll see how it goes. Okay, and so that's that. Okay, academic integrity. Just be honest, right? Do your own work, and you know, if you can't finish an assignment, if you can't, it's okay. Do what you can. Submit what you can. That, you know, when the deadline comes, submit what you've done, even if it's not 100% complete, and just go from there. There's no sense in selling out, trading away your integrity for a few percentage points in your grade. So anyway, that's the thing. There's a good chance that some of these homework problems or homework assignments will give you some struggle, okay? And you know, work through it, okay? We'll talk about that in a second here. Okay, university stuff. Gender discrimination, sexual violence, and harassment. Okay, treat everyone with respect, right? And that's kind of the golden rule. Treat everyone as you would like to be treated. And you know, but if someone was not respectful to you, you know, the university does have resources available. Same with your mental health and well-being. The university does have resources available. I know. Now that you guys are seniors, you've probably experienced, you know, just, you know, life in general can be hard at times, and university is no exception to that. But, you know, as a university and as your teachers, we do want you guys to succeed, and we want you to flourish at school. And so we have a lot of resources made available to help you with that, you know, as things happen. Okay, and if any of you have disabilities, I'm sure you guys are aware of the CAE office, but perhaps you are a transfer student here, and maybe, is this anybody's first quarter here at UCLA? Yes? There's, okay, all right, well, welcome to UCLA, and that's great. And no, well, I love UCLA, so I'm excited for anybody to come here. And anyway, we have resources available. Okay, there's a lot of resources. That's like one of the great things about being at a huge university is there's tons of resources if you seek them out, right? The negative is that there's so many people vying for the same things, but the resources are available. Okay, and this is kind of a tentative outline of what we'll cover, and that's what we have. Okay, are there any questions? Syllabus stuff? No? Okay. I see some familiar faces. I know some of you guys took maybe a class with me either maybe out of order 102C. You guys might have taken like or Stats 10 or something. I don't know. Okay, so here's the our Markdown file for today's thing, and we might not get through the whole thing. That's okay. All right, let's see. Okay, so we're over here. Oh, okay, yeah. Well, oh man, what happened here? Is this gonna load? Let's see. Yeah, okay. I just got a new computer and it doesn't, apparently it can't display HTML files in the browser. What's going on? All right, give me a second. Okay, Google Chrome seems to be working here, so we got that. All right, okay, blah, 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 this is it. And so as we start, I'd like to give you this cheesy thing, my commitment to you. You guys are the paying customer, that's true. And it's my goal that you are completely satisfied with the course and with the teaching that I provide to you in the class. And I hope you will in turn give me good reviews at the end of the quarter. So I see it as my job to educate you in the skills and methods for data analysis and as far as this class goes, in the context of computational statistics. Maybe I don't know, just along the way. I'm always talking, so I want to prepare you guys for what's coming next, right? After you graduate, you're either going to look for a job or maybe go to graduate school, right? Those are kind of, well, I mean, well, anything, right? You could, but those are probably like 90-something% of you will go down either those two paths, okay? And so anyway, that's where we're going. Okay, and I love statistics. I love teaching, and I hope you gain some appreciation of this stuff. Okay, and if you're a stats major or stats minor, that's the way to go. All right. Okay. If you're not happy with anything, let me know so I can fix it. Don't just grumble and complain. I do expect you guys to put forth a good faith effort to learn the topics covered in the course, and I do expect you guys to wrestle and work through any of the difficult topics that I present, okay? Have you guys heard of this idea of a growth mindset versus fixed mindset? Growth versus fixed mindset? Okay, it's kind of like in education, it's like, so sometimes it feels a little bit like motivational speaker stuff, but I think it's for real, okay? And I linked to this TED Talk on having a growth mindset, okay? And
my father was killed by the rebels.
Okay,
My mother died.
It's not even displaying videos here, okay? But we're not going to watch it. But basically, in this TED Talk, he talks about you know, there's this guy. Josh Waitkins, he was a chess champion, and then one day he decides, you know what, I want to learn something else, and then he studied martial arts, and he became a martial arts expert, okay? And the idea that it's trying to promote is that when you face obstacles and when you face failure, if you kind of have a couple options to take, and you can just say, well, you know, I'm just not good at this, and kind of give up there. And then the other is, I'm not good at this now, but if I keep practicing and I keep working, then I'll get better. And I believe that's the case for you know, almost everything. And you know, with computer programming, you know, nobody is born a computer programmer out of the womb, okay? And so it doesn't make sense for anyone to say, you know, I'm just not good at this. Well, nobody was good at this when they first started, okay? It is true, you know, some people may pick up things a little bit faster than you regarding, you know, whatever it might be, okay? But like everything else, if you work at it and you practice and you know, your brain will develop those connections and grow, and you will improve. And so so when you're stuck with a difficult homework problem, I encourage you to work and practice and try to get through it that way, okay? Don't just turn to your neighbor or, you know, a friend and say, hey, how did you do this, and just copy what they did, okay? When you do that, you're not gonna learn as much, okay? So here it is. Okay, so that's what I want. The video is 10 minutes long. I encourage you guys to watch it. Okay. All right. What's this class about? Okay, so it is a statistics course, and so in the big picture of everything, we should ask, you know, why do we bother studying statistics? For some of you, it's because you felt like data science is the hot job and this is the way to go. And there's truth to that, but I would say, you know, at a broad level, statistics helps us gain a better understanding of the world, and specifically, it allows us to make conclusions from data, okay? And the question we're always kind of asking is, you know, what does this particular set of data tell me about the world, okay? Probably in your intro class, you learned how to summarize data. You probably did some hypothesis tests. And the question at the root of all of those hypothesis tests was, could the data I have be a result of random chance, or is it much, or does the data I have indicate that something else is going on, right? And so you calculate your p-value. If the p-value is big, then that means the data could be a result of random chance, right? And on the other hand, if the p-value is tiny, it means it is unlikely for us to have gotten this data by random chance. So the more plausible explanation is that something else is going on, right? So, you know, if you flip a coin and it lands heads, you know, 90 times out of 100, you could say, wow, I just got really, really, really lucky in getting 90 heads out of 100. Or you could say, this seems really strange. I think something is unusual about this coin, right? And in that case, in such an extreme case, we would say definitely something is unusual with the coin. Okay. Blah, blah, blah. Okay, that's what we have with hypothesis testing. So this was an example with a hypothesis test. It says you might start off with a null hypothesis that the mean of the population is 10, right? And in your intro class, you should have learned the central limit theorem. The central limit theorem says that when you take random samples from a population with a mean of 10, those random samples should have sample means that are 10 or something very close to 10. Yeah? And so let's say you take a random sample and you get a mean of 11.3. And so now we have to ask the question, is it likely or unlikely? Are we likely or unlikely to get a mean of 11.3 if the population truly has a mean of 10, okay? And if we find out that there's a very low probability or a small p-value that we get 11.3, then we come to the conclusion that the population does not have a mean of 10. I'm hoping this sounds familiar from your intro stats class, this line of reasoning here, okay? So that hypothesis test and that stuff you went through was based on the central limit theorem, okay? And the central limit theorem says that when you take random samples from a population, as long as those random samples are, quote, large enough, and maybe you had to do some check conditions for applying the central limit theorem, and we said as long as these conditions are met, things follow a normal distribution, right? in your intro class, you didn't have to prove it, but if you took Stats 100B, did you guys take that class? You probably had to prove the central limit theorem in there? No? Yes? Yes, right? Okay, and so you prove that, yes, indeed, the sample mean follows a normal distribution, you know, as asymptotically, okay? And that's great and all. Sometimes, though, that math for applying the central limit theorem doesn't work out, right? Like maybe the conditions for the central limit theorem aren't met, or maybe maybe the problem is different enough that we don't have an analytic solution. We don't have some closed form thing where we can say, you know, according to the rules of probability and mathematical statistics, you know, we've got this mathematical set of rules here, okay? So instead, we might take kind of a brute force computational approach, okay? So instead of trying to figure out the analytics and the formulas for some complicated mathematical situation, we can just run a whole bunch of simulations or a whole bunch of random processes and see what these computationally intensive methods produce, okay? And so computational statistics is just kind of this broad overarching field where we aren't necessarily taking straight math approaches, but we're using the computer to help us get to certain answers, okay? It's not just doing statistics with the computer. We're not just looking straight at data analysis problems, but we are kind of circumventing some of the analytic math, okay? Of course, we can't avoid all math, and so, you know, in later computational classes, there's going to still be math, but the computer is a huge assist for us, okay? All right, I think I said this already. The course can be thematically split into two parts, okay? First, you're going to learn some of the tools, and then you're going to learn some of the methods. Okay, and as far as tools, we'll look at these things. In Stats 20, did you guys cover ggplot? Yeah, okay. And base graphics? Okay, maybe not. All right. Well, we'll probably have a lecture on graphics then. And then as far as computational statistics go, we'll talk about floating point arithmetic, which is how the computer does math, and it's very different from the way we do math. And then some basic numeric methods, computer-based probability, and simulation. And this is on the wrong thing, but okay. R Markdown. Okay, you guys are already all familiar with R Markdown, is that correct? Okay, no, anybody not familiar with R Markdown? Okay, so there's like three or four of you. Okay, so, well, I have a couple slides here, but you know, you can just turn to your neighbor. If you have at least RStudio installed on your computers, those of you who don't have R Markdown, basically you can open the R Markdown file in RStudio. It's just a plain text document. Okay, it's plain text, so if in a pinch you don't have RStudio on your computer, you can just open it and it looks like just plain text, okay, except the ending is RMD rather than TXT. But then the computer understands the plain text and says, oh, you know what, I'm going to render this and produce a nice output. So this presentation was made with R Markdown. It's just, if you look at the text of the presentation, it just looks like this. So if you needed to, you could just, it looks like this, right? Just basically the content, but then you put a little hash mark in front of it, and it says, oh, this is a heading. And then when you render it, it produces everything. And then if you have code, the benefit of R Markdown is that you can have code that gets computed, and the results of those code are integrated with the document that you're producing. So you don't have to run the code, copy and paste the output into your document. You just run the code within the document, and then the document is rendered. Okay. Okay, so basically, if you're not sure how to use R Markdown, just check out this link, and there's some tutorial videos, and then there's a cheat sheet, which everybody should have on just some of the basics of producing R Markdown stuff. Okay, but basically all you do is you just write up your, so if you've never seen it, you just come to File, New File, New R Markdown file, or you just click this thing and you say R Markdown, and then title is test document, author is me, and then it produces this, and then so you can see some code written right here. It says summary cars. This is to produce a summary thing in R, and if we ran summary cars in the R console itself, we can see the output of that code being run. We can also preview that output by clicking the little play button here, and it produces that output right here. But then when we click knit, it runs it, and it will render our document right here. Okay, and so you can see pretty much all the text here, and then the code that gets run shows up here, and and if you have code to produce a plot, it also produces a plot as well. So anyway, R Markdown is pretty excellent. So that's what we will be using. But if you guys are already familiar, then there's no sense in reviewing that. Okay, so we'll do that. Okay, so now we'll get started on actual stuff that we'll talk about, and so our first portion will be on data structures in R. Okay, and I think you guys are familiar with some of this, but we'll get into maybe a little bit more heavier detail here, right? Okay, so the primary things that you will be using are either atomic vectors or matrices. Okay, we also have lists, and we have data frames. Those are primarily the kind of the four main data structures that you're working with. And if you want things of higher dimensionality, you have also the array. Okay, there's other kinds of data, but these are probably the ones that we use most frequently in R. Okay, so atomic vectors and lists are one-dimensional. Okay, so things you can just think of kind of a line of values, and then the matrix is kind of a rectangle of values, and the data frame is also a rectangle of values. Okay, you see the column heading here is homogeneous, meaning that everything in the atomic vector, the matrix, and the array have to be of the same data type. Okay, if you've got numbers, then it can only be numbers. If you've got characters, like letters and stuff, then the entire thing will be treated as character or letters. Whereas with a list or a data frame, those things can have a mixture of numbers and character data or other data types as well. So this is what we have. Okay. It's great that you guys are taking notes. If you don't feel like taking notes, all of this is put on CCLE, so you can, I don't know, download this and annotate it up as you're watching, or you can just sit back and not relax, but pay attention, right? Okay. We have 6 basic atomic vector types. We've got the logical vector, the double, integer, and character. Okay, there's also complex and raw, okay? Logical would be kind of your trues and falses. The double is pretty much your numbers. Anything with a decimal point is considered a double. Okay, integers will be numbers but no decimals. Okay, and then characters will be everything else, right? Words and such, okay? Complex is for imaginary numbers, and raw is kind of like hexadecimal computer values, but we don't really use these, okay? The column heading here is type of, okay? Type of is what we use to figure out the basic value, okay? You guys might be used to using kind of like a command called class or things like that. Class is an object type. It's different. If you want to know the basic atomic vector type, the command you're using is type of, okay? Storage mode is it's kind of like a legacy thing coming from S. If you don't know the history of R, in like the days of Bell Labs, when they developed the computer language C, they also developed a language S, okay? And then R is kind of like the open source version with its history in S. But anyway, okay. All right, so atomic vectors are homogeneous, meaning that all objects in the vector must be of the same type. So if you have a logical vector, then everything in there has to be a true or false value, okay? In R, I strongly recommend typing out the word true in all caps, okay? Because the word true in all caps is a reserved word. So when you have the word true, it's always going to take on the value true. Whereas if you type in T, R is pretty smart and will say, okay, T is going to be true, okay? And then you type in F, it will also figure out that it's false, okay? However, in the course of your programming, you can do something like this, right? And then now, if you have T, it takes on the value 0, right? And then so if you've got something like if T print hello, okay, it doesn't run because it looks at this and it says, oh, T is 0, this if statement is false, okay? I know we haven't gotten to if statements yet, but you can reassign, you can change the value of T, okay? You cannot change the value of true. If I try to say true is set this thing equal to 0, it's not going to let me do it, okay? Now, if I take on some other thing like this, it doesn't care, okay? This is now just some random object named true. So I encourage you to use the all caps true because that's a reserved word. It's not going to ever take on anything else, okay? In Python, they spell things differently. They use lowercase, but whatever, okay. So that's what we have. Okay, this is a logical vector. We say type of this thing, it's going to say logical, okay? You got character values, so you've got the word hello, that's going to be a character vector. Or if you have multiple values, you combine them using C to stick them together, these are still character values. So if I got B is combine Adam, Bob, okay? So this is a character vector, and I say type of, and that is character indeed, okay? And single or double quotes will indicate to R that this is character data. Okay, double is floating point numeric values. Yeah, you might ask, where's single? There's no single in R, okay? In if you learn like C and stuff, you know, you have like single precision and double precision, and it's like how, and they both store decimals, but the single you have like fewer decimal places, and the double you have more decimal places. In R, that's just double, okay? It was a bigger issue when we had like memory issues, but you know, all your computers now have what, 4 gigabytes, 8 gigabytes of RAM, and this takes up what, 6 bytes, 3 bytes? It's not a big deal, okay? So so this is it, all right? You type in 1.33, that's a double, okay? The default number type, if you type in 4, okay, it's gonna say type double. You say, well, there's no decimals there, okay? This is just the default numeric type, okay? You create a vector, the value is 1, 2, 3, that's type double, okay? So what about integers, okay? If you want to explicitly have an integer and you're gonna type out the number, you've got to put in an L, okay? An L makes it an integer. So you say 1L, and that is, okay? It looks like the value 1, right? But, and let me just store this as D here, okay? So D looks like the number 1, it looks like the same, but if you say type of, okay, it will tell me that it's integer, okay? And if you use the colon notation, right, like for I and 1 through 100 or something like that, if you use the colon notation, which is kind of the shorthand for all the numbers 1 through 10 or something like that, this is, so if I do D is 1 through 10 and I say type of, that is also integer type, okay? And you can also see in the environment, it produces this. It says this is type integer, whereas the values 1, 2, 3, and 4, this is numeric, or it says numeric, but it's type double, okay? So there's a difference. All right, you use the function C to kind of combine values together, right? You combine 1, 2, 3, and you get the vector 1, 2, 3. You combine hello and world, and you get the vector hello followed by world, okay? And then with the command C, it's flat, okay? So you can't, like if you nest a C inside another C, it just flattens it out, and it's the same, okay? This thing and this thing are exactly the same, okay? So you nest vectors inside of each other, it just gets flattened out by R. All right, and you can always ask the type. You can say type of X, right? Or if you need a true-false value, you can say, is it logical, character, double, or integer, right? Or you could say type of X equal to logical or whatever, right? Numeric will return true if it's integer or type double. All right, so what is this going to be? Is integer 3? False, right? Is integer 3:6? True. Is numeric 3:6? True. Is double 3:6? False, right? Okay, 100% everybody, okay. Is atomic returns true if it's an atomic vector. Is vector returns true if it's any type of vector, which is going to be an atomic vector or a list. A list is also considered a vector, right? Okay. Coercion. All right, so R is a dynamically typed language, which is awesome, but also has its drawbacks, okay? So this just means you don't have to say X is going to be type integer and only put in integers into X, okay? If you have X to be integer today and then like 2 minutes later you decide to throw in a character, it's going to be fine, right? And with an atomic vector, everything has to be the same data type. So what it's going to do is if you combine a double, this 1, with character hello, it has to turn everything into the same data type, so it coerces everything into type character. Okay, you've got logical with an integer, it coerces them into integer, right? You've got double and integer, it coerces them into double, right? So the way it's going to do the coercion is it looks at the least restrictive form in that thing, and then it coerces all of the objects into that form. So logical is most restrictive, then integer, double, and character, okay? So here I've got logical, integer, double, and character. I've got 4 different vectors of these different data types. And then, and if I put logical, integer, and double in there, okay, double is the least restrictive, so it coerces the logicals, the true, falses, and trues into type double. So you get 1, 0, 1, followed by the integer 1, and then the doubles 5, 6, 7. Okay. Whereas if we have type character, L, D, and C, then the character type is logical double. It's going to look at the character, and then so the logical true, false, and true get coerced straight into character. So it skips the 1, 0, 1 phase and goes straight into characters of true, false, and true. Okay. Oh, notice. So I have L, I, D, and notice I didn't call the character vector C. Why didn't I call the character vector C? C is not a reserved word, but C is a very important function that we use to combine vectors, right? So if in your homework, somewhere along the way, you're like going through A, B, C, D, E, don't name the thing C, okay? Because C is a function that we need to combine vectors, or combine values into a vector. And if you call something C, you're going to break it. You can explicitly coerce things using as.numeric or something like that. So here we've got false, true, false. And if you coerce them as numeric, you get zeros and ones. And then if you have the function sum, it just coerces these into the number. And if you take the mean, it coerces this into this. So this is kind of a shortcut. Like a lot of other languages, you can't do this. You can just say, give me the mean of a logical vector, and it's going to give you the proportion that's true. Okay? All right, looks like we've run out of time here, so so we'll stop here, and then we'll see you guys on Monday. So have a great weekend, and I'm looking forward to a great quarter.